Now we start with the three presentations on the results we have achieved in the Code Reality project and in the wider community. We start with the presentation on the Model Augmented Reality Curriculum, which will be by Fridolin and myself, Mikhail Fominykh. I should also mention that this work we are presenting in this short presentation is not only done by the two of us or not only done by Code Reality, but it has been done in a wider community. And we have been very happy that we received support from the ITiCSE conference, Innovation and Technology in Computer Science Education. And that our group that has been working on the curriculum has been joined by a number of prominent researchers and educators in the field, and that also we are very open in continuing developing the curriculum, and you're all welcome to join there. I would like to actually invite Fridolin to take over sharing the screen at this moment.
Yes. Hello. So, yeah, it's we're standing on the shoulders of giants, but happy to present here the outcomes from our Model Augmented Reality Curriculum Working Group. We all know augmented reality has been around for a while. In my reading, it's at least from the 16th century with Giambattista della Porta, but for many, augmented reality starts here with Pepper's Ghost, a theater installation that, surprise, surprise, is still using quite similar technology as we would use today. But only in recent years, technology has advanced so far that it is mainstream, and Gartner has moved it now out of the hype cycle as it has passed the peak of inflated expectations and gone down through the trough of disillusionment over the years. And we're somewhere now on this plateau of productivity, no longer an emerging technology. Some people are even saying that a big shift is coming, and augmented reality is part of this big next wave of personal computing, where reality and virtuality become indistinguishable. And it might be difficult at times to figure out which one you're in, or at least which ones your colleagues and friends are in right now. The working group, and here I mean those are the key figures that we have been collaborating with, included colleagues from around the globe. So it's Mikhail and me, from Mikhail here, NTNU and Molde University, me at the Open University and Oxford Brookes, Ralf from Aachen, the German MIT equivalent, so to say, then Mark from University of South Australia, Leah from the University of Oxford, Andrey from ITMO University in St. Petersburg, Eleni from University College in Dublin, Judith from Molde University College, Ian from California State University East Bay, Marius from Mines Telecom Paris, and Aljosa from Trinity College in Dublin. We have come together as we all teach augmented reality for a while and are rooted deeply in the communities, so as to get together the following things: a review of the state of the art, skills framework, and a set of resources.
In the framework of this working group on the development of the curriculum, we've continued the survey of teaching practices, and our survey has found a wide range of AR training offers, both in and outside of the computer science. So AR today, as you have also seen in the panel, is taught at different levels in a variety of disciplines, and in the consequence, the industry does not always know what skills to expect. We found even that the same university may offer different courses at the same time at different departments, and these courses do not complement each other. There are other examples where such courses are actually designed to complement each other, but not always. One of the challenges we see in teaching AR and in particular in designing the curriculum is that the course offers are often monodisciplinary. They focus on one perspective, either HCI, information systems, software engineering, communication design, but very rarely, very few courses focus on the combination of these. We found a few examples of those multidisciplinary AR courses, but not many. The challenge is perhaps similar to the other hybrid areas that require both creative and computer and other skills, such as, for example, game development. But for the augmented reality, this challenge has not really been addressed. And in our working group, we are trying to do that. What we also found is we found different examples of multiple courses in the same universities, different specializations where the augmented reality topic comes in is an alternative in the end of a study program or a course. We found many online offers, but very few large enough courses that actually introduce theory and introduce a comprehensive point of view. We found some commercial offers. Most of them are very short-sighted, focusing on specific tools and not covering fundamentals, although, again, with some examples, with very few comprehensive commercial offers. We found also several industry academia partnerships in teaching augmented reality. And these are, for example, in the medical augmented reality or partnerships with producers of hardware. So as a bottom line, there is no agreed curriculum in the professional societies, and therefore there is no foundation for independent auditing or accreditation. There is no third-party audit through any professional societies possible at the moment. There is no institutional body or there is no expert commission that actually would revise and update a recommended augmented reality curriculum. And this is something that we would like to work on and to introduce and to start. Back to Fridolin.
So that's what we have changed. We have assembled this committee of experts to come up with the following skills framework. This is a conglomerate of the things that we consider relevant for teaching augmented reality on an undergraduate or postgraduate level. 12 groups of skills. That's a little bit advanced from the original AR4EU study that we did with 10 groups of skills. We split out a couple more. For example, the human-computer interaction skills down here are a bit refined, as well as the new group of user evaluation skills. And otherwise, it's covering similar areas, general development skills with platform-specific skills, then advanced data analysis and AI skills, audio engineering, advanced computing skills, hardware-related skills, then also new area design and rapid prototyping skills, including also then user-centric design approaches, computer graphic skills, computer vision skills, and of course, specific language skills. So this group of 12, the lucky dozen, is what augmented reality specialists should in one form or the other provide as with regards to the hard skills. And that of course then ties in any modern education model with a lot of rich professional skills such as time management, planning, project management, and so on, but they're not explicitly listed as they are generic to many programs. We then set out to make a recommendation from this curricular working group to what should be included in an undergraduate course here on the left, and what should be included in a postgraduate course on a master level here to the right. You may be attempting to read this all now in one, but let me just point you to the most important bits. All those that have 4 dots are what we consider mandatory. All those that have 2 dots is something that should be added. All those that have 1 dot are kind of electives. You would want a good share of those, but you wouldn't want to cover all of them necessarily. So amongst, of course, the 4-dot mandatory elements, we would have an introduction to AR, which is different in both cases. We'll see that in our Code Reality open educational resources offer in a little while. They deal with the introduction in different depth. Then on the foundation course, there would be a more extensive introduction to perception and available technologies, as well as then to HCI evaluation methodologies and spatial computing. On the tutorial side, we would have the Unity introduction, for example, or its alternatives, Unreal or others. Then something on markers and image targets, as a core technology that is still very relevant, as well as its counterpart, modern SLAM-based AR with spatial mapping. And then the 3 different types of interactions: gaze, gesture, and voice. On the advanced course, it is a bit different with the mandatory elements. So there's a bit more about AR UX and how you engineer user experience. There is then our recommendation to add a deep introduction to computer vision, not just using toolkits, but also being able to build toolkits, and more practical skills as well then as with regards to evaluation. Of the tutorials, a computer vision tutorial we consider mandatory, collaboration and sharing facilities we consider mandatory, and then spatial understanding as a more advanced one, complementing the spatial mapping. The should recommendations then depend a lot on what is already offered in existing programs. So of course you wouldn't do things double. You would only offer them as part of one module and not twice if they're already offered somewhere else in the program. And some of the should elements are alternative. They depend a bit more on the kind of flavor of education you would want to provide. A note about program integration, and that's maybe also relating to our earlier panel discussion point about the balance between theory and practice that we haven't discussed at length. Generally, in all programs across the globe, the amount of lectures and tutorials is only a very small share. And in Europe, for example, but also in the US, in Australia, as well as in the UK specifics, any course offer with a regular module size of 7.5 ECTS points would include a lot of extra hours. And those extra hours come for exam preparation, they come for, which is still a minor share, but they come largely for independent study. So the practical element, or the element of writing a course paper, takes up the majority of the time. The independent self-study of students takes up the majority of time, while lectures and tutorials in our recommendation have a maximum of 22 times 1.5 hours for the foundations course and 29 times 1.5 hours for the advanced course. Having said that, it really depends on your selection. This can be a lot less hours, and just balancing it a bit more with the requirements done to the independent study. Yeah, of course, it is possible to create different sizes of courses, and we have seen that in the past. So there are smaller, more lecture-oriented courses that would then have 4 ECTS points or even less, and a fully fledging module would have 7.5 ECTS points, or here in the UK that's equivalent to 15 CATS points. We also identified useful assessment regimes of how you would want to conduct the assessment, and we identified 4 different types that are recurrently used in teaching augmented reality. The classic final outcome, so that attendance doesn't matter that much. It's more of what you actually produce. Then a report, video, and code is a good recommendation. Yeah, then with, for example, assessment criteria distributed like this: originality, creativity 30%, quality result 30%, report 40%, but others are of course possible. 2 types of team projects: a classic team project with interim reviews and then a final assessment of the coursework, weight much higher, or the 4 reviews format, where you would have first review emphasizing market analysis and technology survey, the second one then mock-ups and possibly already tests, the third one a demo and test and documentation, and then the final one would be done more in a sort of business pitch with the full documentation available and the source code properly managed. Or the 3 assignments way of doing things: the first one doing a virtual reality scene, the second one doing an interactive scene, and the third one then developing a handheld mobile AR application and a 10-minute presentation a research paper in class. For the documentation required to install courses, of course, you will have to make up your mind about intended learning outcomes, and we made a recommendation for both of them. But of course, any such intended learning outcome scheme needs to be fine-tuned to your local requirements, and some universities do have skills frameworks that you should align with to make sure you're hitting the tone right, and it also fits into the rest of the programs and is complementary and fitting in rather than something that requires additional work then. Yeah, the AR curriculum working group has now, for now, concluded the work with the final publication outcome appearing in the next couple of weeks. And if you drop us an email, we happily will send you the preview paper already. It will be open access as well. And it was supported by ARET, the Code Reality AR4EU Consortium, and Fantasia. Thank you.